Hi everyone, I hope you all are doing good. So, in my today's session, I'm going to explain about one more behavioral pattern called state, or you would call it state design pattern. Okay, so let's start with it. What problem state design pattern solves? So, basically, the problem is that an object should change its behavior when its internal state changes. Okay, first requirement. State specific behavior should be defined independently. That is, adding new states should not affect the behavior of existing states. Okay, so these are the two main requirements or two main problems that state design pattern solves. Implementing state specific behavior directly within a class is inflexible because it commits the class to a particular behavior and makes it impossible to add a new state or change the behavior of an existing state leader, that way breaking the single responsibility principle independently from that class. Okay, without changing the class, also breaking the open close principle. Okay, so what happens is, suppose you have written a business service class. Okay, and that particular business service, okay, say I you call it I order service. Okay, so this order basically changes its behavior based on various states or various inputs, you would say. Okay, so what happens is, if you don't follow the state design pattern, what happens usually, this service class, order service class, will end up with having a lot of if else ladders. Basically, okay, if state is this, or if value of some product is this, do this. If the value of, or if the state of the order is this, do that. So like this, n number of states will come into your service class, and that service class is very difficult to modify later. Okay, so that's why, in order to avoid this kind of spaghetti code, we should make use of state design pattern. Okay, so again, ends up in breaking single responsibility principle if you don't follow this pattern, because what are you doing? Okay, that class, that particular order service class, is doing a lot of responsibilities based on your various states. And apart from that, whenever you introduce a new behavior to your service, or whenever you introduce a new state to your service, what happens? You have to again write one more if else block, which is basically a code smell, and thus you are breaking open close principle. Okay, so how it can be solved, let's see. So first, understand what is state design pattern. The state allows an object to alter its behavior when its internal state changes. This pattern is close to the concept of finite state machines. Okay, so state design pattern is always correlated to the concept of finite automata or finite state machines. Okay, I think you would have learned in your engineering days. The state pattern is used in computer programming to encapsulate varying behavior for the same object based on its internal state. Okay, it is the same object but based on its internal state, or I would say in simple terms, the class member variables. Based on the values of your class member variables value, the behavior will keep on changing. Okay, so this can be a cleaner way for an object to change its behavior at runtime without resorting to conditional statements, the spaghetti code which I already explained, and thus you can improve the maintainability of the code. So how we basically implement the state design pattern? Okay, so the state pattern describes the following solutions. The state pattern suggests that you create a new classes for all possible states of an object and extract all state specific behaviors into these classes. Okay, so first thing what we have to do is, okay, first we have to create new classes for all possible states of an object. For example, take an example of television. A television is in off state. Okay, so then it will go to on state. From on state it may go to chromecast mode. From chromecast mode, okay, it may go to your local cable operator or dish tv mode. Okay, from dish tv mode, if your tv supports some extended features like built-in radio, then it can switch to built-in radio. Same object, basically same object. Whenever you press the buttons on your remote control, okay, it is changing its behavior. Okay, so what you have to do, the state pattern suggests that you create new classes for all possible states and object and extract all state specific behaviors into these classes. So if there is any additional behavior needs to be implemented, that behavior also needs to be extracted into state classes. I'm going to explain with the demo soon, but just for your information, I am giving an example of television set. Okay, instead of implementing all behaviors on its own, okay, the original object called context stores a reference to one of the state objects that represents its current state. See, instead of implementing all behaviors on its own, the way I already explained, a typical scenario where suppose you have not followed the state design pattern, and in a service class, okay, or in a client class, what you have done, you have put all the behaviors and states related logic. Okay, so instead of implementing all behaviors by its own, the original object called context stores a reference. You have to create a context object, and in this case the context object is your television. Okay, and store a reference to one of the state object that represents its current state, usually one state, the current state, and delegates all the state related work to that object. Okay, to transition the context into another state, replace the active state object with another object that represents the new state. So for example, if I have a context class called television, it contains its current state variable. Okay, so current by default it's in off state, so it will be holding a object reference of off state. The moment you press the power button of your remote, it will enter into on state. So what happens, to transition the context into another state, that is from on off state to on state, you will basically replace the current state object by the new state. Okay, so that's all about this pattern, how it basically provides a solution. One important thing, this structure may look similar to the strategy pattern. Yes, I think there is a resemblance with the strategy pattern, but there's one key difference, guys. In the state pattern, the particular states may be aware of each other and initiate transitions from one state to another state. For example, take the example of TV. Okay, you know your TV will be by default in off state, then it will go to on state, then you will put into multimedia state or radio state, whatever state you want. Okay, but in case of strategy, okay, you almost never know about each other. Basically, in case of strategies, what happens is you don't know what strategy is going to be implemented in the next state or in the next period of time. Okay, so it all depends on the program basically. Okay, and the program decides using the strategy pattern what strategy it should make use of. Okay, so that's the difference basically between these two. So when to use this pattern? Use the state pattern when an object changes behavior depending on its current state. Okay. The number of states is huge in number. Okay. And the state specific code changes frequently. Okay. What they are saying is use the state pattern when an object changes behavior depending on its current state. The number of states is huge in number and the state specific code changes frequently. Mark this statement. Okay. Use the pattern when you have a class polluted with too many conditionals. Okay, okay, this is also an indication where you can apply this pattern. So you have a service class or a state machine class. Okay, and that state machine class is basically polluted by too many conditional statements based on the state values. Okay, and that's what they are saying. Use the pattern when you have a class polluted with the too many conditionals that alter how the class behaves according to the current values of the class fields. Okay, in such cases I think this pattern can be a candidate to use it as a solution. Use a state pattern when you have a lot of duplicate code across similar states and transitions of a condition based state machine, as I already explained. Okay, so let's move on to the UML class diagram. Okay, so this is the context object or the context class which contains a reference to the state or the current state. Okay, which holds a pointer reference variable to your state or I state, you would say, interface, which contains one or n number of operations. Okay, depending on the number of operations that depending on the number of behaviors that needs to be exhibited for that state. Okay, and then what happens whenever an operation is called on context, indirectly the context will hand over that operation to state dot operation. Okay, so the concrete implementation of that this particular state will be triggered by this state dot operation from the context class. Okay, so you can see the timeline diagram also. Okay, so it would be better if I explain this with an example. I think that will make many things clear. So let's move on to the code window now. Okay, so this entire pattern is cornered around the state basically. So let's start with the abstract state the abstract state class or abstract state interface. So I have made use of an interface over here, so you can go with abstract class also, not an issue. So first of all, what I'm doing is I will specify what are the various states of my context object. In my example, it is a television set. Okay, so for my television, okay, what are the possible states? Okay, so this particular contract or interface specifies all those possible states or the behaviors, I would say. See, press power button, okay, which will turn on the TV, okay. Press broadcaster button, which will put the TV into dish TV mode, the cable operator mode. When you press multimedia button, it will put your TV into Chromecast mode. When you press the radio button, if your TV has a radio hardware, in my case, yes, it is has, so it will turn on the radio. And if you press the sleep button, it won't turn off, but it will go to the sleep mode. These are the all possible states my TV will go through basically. Okay, so now once I specified my interface, okay, which basically exhibits all possible operations from my context object, which is television. Now see the concrete implementation for this I state. The first is on state. Look at the beauty of this pattern. Okay, no if else conditions. Okay, so what you are doing, you are basically for each and every state, what you are doing, you are basically implementing that interface and creating a new class. Okay, these are the behaviors. Okay, and for all of these behaviors to trigger, you need states, so all those state classes will come here. Now public class on state implements I state. Okay, and then you will provide the implementation. So when your TV is in on state and if you press the power button, okay, see TV is already on, going to the sleep mode. Okay, so this state itself represents the on state, and being in the on state, if you press the power button, TV is already on. Okay, so it is going to sleep mode basically. Okay, so then if you press broadcaster button, TV is already in on state. Okay, now it is going to dish TV mode. If you press the multimedia button, it's already on, so yes, you can go to the Chromecast mode. Okay, so yes, TV is already on, you can go to radio mode. Press sleep button, TV is already on, now it is going to sleep mode. Okay, so here, that is the on state basically that I explained over here. And as they explained the on state, now in the similar way, I will implement the off state. What will happen when you are in off state and if you press the power button, TV is in off state, so it will turn on the TV, and same will apply for other operations. Okay, when it is in off state, see what it is seeing, TV is turned off, cannot start dish TV channel. Okay, so these operations are prohibited when your TV is in off state. Okay, guys, do understand the state, see how it is behaving now with the off state, what operations are possible, what are not. Yes, you can turn on the TV, but you can't you can't when a TV is turned on, you can't see the broadcaster channels because TV itself is off. Same applies for all other. Okay, it's turned off, you can't start multimedia radio. Okay, and TV is in off state, you can't put the TV into sleep state because it is turned off basically. Okay, sleep state. So again, TV is in sleep mode, when you press the power button, it will turn on the TV. So when a TV is in sleep mode, if you press the broadcaster button, no, it will eventually end up in turning on the TV and it will switch to dish TV. So TV support this functionality. Okay, so same for others basically. Chromecast state same as the dish TV state I already explained. So instead of dish TV, what it does, it will basically, yeah, it will basically change to Chromecast mode. Okay, so press power button, TV is in Chromecast mode, turning off the TV. Yeah, because it is on, it is in already in Chromecast mode, and if you press the power button, it will turn off the TV. Okay, press broadcaster button, TV is switching from Chromecast mode to dish TV mode. Okay, then multimedia button, TV is already in Chromecast mode, so if you press the multimedia button being in Chromecast mode, that means it's already in Chromecast mode. Okay, so it will just say this message. If you press radio, it will turn on the radio, and if you press sleep button, it will switch from Chromecast to sleep mode. Like that, I have created radio states. So these are the various states I basically created by inheriting that I state interface. Okay, now This is my driver class or my app class. That's the main method. So before initiating any kind of operation, first of all, I have a context object which is my television set. So if you go to television set, most important thing, this is the context class when it comes to state design pattern, and this context class should also inherit or implement that iState interface, and then it should hold a reference to the current state, which is iState. Okay, then in the constructor you can initiate a default state for your TV, that is the current state. So by default it will be an off state, so I have assigned off state. But if you want to set some other state, you can use the public method set state to set the initial state for your TV. Okay, so this is how your context class will be. Then the methods from iState interface, what it is doing basically, whenever you invoke this method on your context class, simply it will, what it does, simply it will invoke the same operation on the current state. Okay, so if you press broadcaster button, so using that current state, whatever current state you have on that state, it will perform that operation and it will let you know whether that operation can be performed or not. Okay, if your TV is on, then only you can go to broadcaster state. If the current state is off state, then triggering this method or calling this method will give you a message that the TV is turned on. You can't go to broadcaster state. Okay, so that's all about it. So the current state basically contains what state the TV is in, and then calling the methods will give you those messages. So it may contain a complex business logic, but for demonstration purpose, I'm making use of these simple classes. Okay, so the next step, after invoking the desired operation on the current state, now what you have to do, you have to set the state to the desired state, that is press broadcaster button. Okay, you have to put it into the dish TV state. Okay, so this is how it works. There are possibility you can put a conditional statements also. For example, I have put over here, because power button has two functionalities. Okay, if the TV is in off state, it will basically turn on your TV. If the TV is in sleep state, right, it will brings your TV into on state. Okay, these are the two functionalities are there for power button basically, which basically works in two different contexts. So I have put a if condition over here. So if it is off state, turn on. Even if it is sleep state, turn on. Okay, and then for the radio, the moment you start the radio, the current state of this TV will switch to radio state. So that's what I'm doing using the set state method over here. Okay, which is this method set state. So whatever state you pass, it will set over here. Okay, very simple implementation. So I will run this program. So let me show you the output. So what all operations I'm doing on my client basically, or the user. Okay, this main method is a user. Now what he did, he basically has a TV set in his house, and what he did, he pressed the power button first. Okay, and then he changed to broadcaster mode, then he changed to multimedia mode or Chromecast mode, then he changed to radio mode, then he sleeped the TV, he made his TV to go into sleep mode. Okay, then again he pressed the power button, and then again he pressed the power button. I will show you how the internal state changes between these two. Okay, so if I open the console where the program ran successfully, the initially TV was in off state, turned on the TV. Now what he did in the second step, okay, the first step, he pressed the power button in his remote control, and TV from off state it went to on state. Then what he did, he pressed the dish TV button. What happened, the TV is already in on state, now it is going to dish TV mode. See how it is changing the state, guys. Okay, now being in the dish TV mode, the guy, what he did, he or she, okay, they pressed Chromecast button. Now the TV is basically changing from dish TV mode, it is in dish TV mode, now it is switching to Chromecast mode. Now being in Chromecast mode, what he did, he pressed the radio button. Now TV is switching from a Chromecast to radio mode. Now he is not happy with the radio also, so what he did, he pressed the sleep button. So the TV is switching from radio to sleep mode. And after some time, what he did, he or she again, he or she pressed the power button. Okay, so when he pressed the power button after sleep mode, the TV was in sleep mode and it was turned on. Eh, what that guy did, again pressed the power button. Okay, the TV is already on, now it is going to sleep mode. Okay, so this is the basically state transition which took place. Okay, and every time whenever you basically performed an operation, whenever you gave an input, these are the inputs. Okay, based on that input, or you would say state, the behavior of the TV is getting changed. It is changing from one mode to another mode. Okay, guys. So a trivial example, I think, I hope you people understood how this particular pattern works. Okay. So this, so as already explained, so you should make use of this pattern when an object changes behavior depending on its current state. Okay, the number of states is huge in number. My TV's example has almost 5 to 6 states, so that's why I implemented. Okay, so this is the use case scenarios you should go through. Basically, you should analyze your requirements, business requirements, and if they satisfy all these conditions, no, then yes, you can go ahead with this state design pattern. Okay, pros: single responsibility principle will be respected. Basically, organize the code related to particular states into separate classes. Okay, you are respecting single responsibility principle by putting each and every state code into its own class. Open close principle: introduce new states without changing existing state classes or the context. Yes, again, you are respecting the open close principle also by not introducing new conditions into your context class, which is TV, and the state classes associated with your TV. So for new state, you are creating new state class. For a context class, you are basically introducing a new method, no if else condition. See here. Okay, no if else condition, all have their own respective method. So you introduce a new method, a new operation in your state. Okay, and that will be implemented by your context object. Okay, so simplifies the code of the context by eliminating bulky state machine conditionals. So simplifies your code by eliminating all the if else conditions in your state machine or your context class basically. Okay, so these are the pros basically, and cons being applying the pattern can be overkill if the state machine has only few states or rarely changes. If it has only one or two states, okay, then there is no need to apply this state pattern, guys. Okay, and when these states change very rarely basically. Okay, it has very minimal states like one or two, or say less than five. Okay, and state changes happen very very rarely. In such cases, go with this, don't go with this design pattern. Okay, so that's all about state design pattern. Okay, thank you for listening, and have a nice day, guys.